Hi, this is the supplementary video for Lookout, Diverse Multi-Future Prediction and Planning for Self-Driving. The future is inherently uncertain and multimodal. In particular, the self-driving vehicle is not fully aware of future trajectories of other agents, or even their goals. At a three-way intersection, like the one depicted in the image, there are at least two likely futures. On the left, the other vehicles yield to the self-driving vehicle, or SDV for short. On the right, the SDV must brake before entering the intersection, since the oncoming vehicle is taking an aggressive left turn. In this work, we propose an approach to both predict such diverse futures at a scene level, as well as plan safely for the distinct futures. The inputs to our model are a history of LiDAR point clouds and a raster map. We extract the global scene context with a convolutional backbone network, perform object detection on top of it, and extract local context to each actor, which we denote as X. Then we generate a set of diverse samples using a graph neural network, where each sample symbolizes a different realization of the unobserved scene dynamics, which can encode the other agent's goals, for example. Then we decode the future trajectories corresponding to distinct realizations of the future using another graph neural network for all lanes in parallel. Finally, before passing these to the motion planner, we reason about the probability of each future in the set so that the decision-making can plan contingent trajectories according to their likelihood. Finally, a multi-future planner plans a safe maneuver for each possible future. Let's see in more detail how this is done. In contrast to prior works, where a single trajectory is selected that is good in expectation, we propose a contingency planner that exploits the fact that only one of the predicted scenarios will happen in the future. In this case, either the red or the blue one. Therefore, our contingency planner finds an immediate action that is safe with respect to all scenarios and allows a proper response to each future realization. In order to find the optimal action and corresponding contingent plan, we first sample such possible pairs. Specifically, we sample a large set of actions in the form of short-term trajectories. Then for each action, conditions on its end state, we sample a set of long horizon trajectories. For each action, we find the optimal response to each scenario from the corresponding long horizon trajectories. First for the blue future scenario, and then for the red future scenario. The cost of the action is computed by the expected costs of the contingent plans and the cost of the actions itself. As an example, the cruising action on the left is costly because the safest response to one of the future scenarios includes a hard brake and hence high cost. In contrast, the light braking action shown on the right enables safe and comfortable contingent plans for the future. We first showcase the motion forecast generated by the Lookout model. The predictions here are displayed in red, yellow, and the best long horizon trajectory for each individual sample is shown in blue-green. We can see here that several multimodalities are represented for the slow-moving vehicle here, from a U-turn to forward acceleration. On the other hand, a forward driving versus right turn behavior is predicted for the faster-moving vehicle here, balancing realism with diversity. Here we can see the left-turning vehicle has a different speed profiles predicted, which in turn affect how quickly the SUV accelerates forward while maintaining safety. Our model is encouraged to sample sets of scenes such as these that vary the motion plan through a planning-based diversity loss. Finally, we can see an example here of scene consistent predictions. In the top intersection, one car passes the other only if it's safe to go, such as if the first car has passed straight in front. Now we showcase our model in closed loop simulation. The SDVs at the center in green, and the other vehicles and their trajectories in blue, and finally the pedestrians in pink. Let's focus on the diverse predictions and response from the planner. The short-term action planned in the SCV is plotted in black, and the contingent trajectories are plotted in different colors, which in this case accounts for the variations in the speed profile of the left-turning car. As you can see, the SCV passes the intersection safely and cruises smoothly. In this scenario, the SDV plans different accelerating trajectories to be safe to unlikely samples from oncoming traffic coming into our lane and successfully goes across the intersection. Here, our model avoids the hard brake before making the left turn by planning safe contingent trajectories to the diverse speed profiles from oncoming traffic and smoothly effectuates an unprotected left turn in this fast-moving scenario. Here, the car in front of the SUV might turn or go straight, and thus it might potentially brake before turning. The SUV plans both cruising and braking trajectories to safely account for that, and it comfortably drives through the intersection. Finally, we show that our planner can stay patient and avoid a swerve even when there are predictions coming at it, but there's still time to react. That was Lookout, Diverse Multi-Future Prediction and Planning for Self-Driving. Thank you for listening.